Welcome, my kiddies. You're joining me for part two, and we're going to discuss the most important construction principle regarding all of these ancient sites. So, in the first part of this series, I covered a different principle that was regarding our daily life, and let's just go over it in case you missed it. I'm just sort of warming up your head to it. This is going to be the shittiest diagram on the internet discussing one of the most important construction principles out there. So, I saw this triangle in some book some time ago, God knows where, but it's very basic. So you have three aspects of your life. This is like the fulfillment or the happiness triangle, right? So you have love, health, and wealth. Love does not have to be romantic love. It can be love for your animal, love for the world, love for your garden, love just as in like just sharing with people your experience, right? There's lots of different types of love that people find in this world. So this triangle is not this Captain Obvious three aspects of your life that are super important. It's a diagram that shows that these three aspects of your life are entangled. They're codependent. And I'll explain. So if your love begins to suffer, let's say we cross it out. Again, not romantic love, but any kind of love. It is very likely that your health will be compromised. And if your health is compromised, your wealth is compromised. If you're just like a robot with no love in your heart, right? We're energetic beings, we're electromagnetic beings, emotional beings. When you have emotional blockages, it manifests into the physical reality. So with no love, you're likely to develop health problems. You're going to look like a freak, and your wealth might suffer as well. So with love compromised, health and wealth are compromised. With compromised health, this one's really obvious, right? When you're dying of cancer, the last thing you're thinking about is trying to get laid or romantic relationships, or you're scared to lose everything that you love, right? So this is compromised. This aspect of your life is very compromised. And wealth, I don't need to go into that. You're going to stop making money when you die soon. So health compromises love and wealth. And if wealth is compromised, you're broke. Well, shit, you're not going to have any money for healthcare. You're going to be eating junk food. You're going to be living on the street. You're going to be dirty. So health is obviously compromised, and nobody likes a broke idiot. It's difficult to get along with people when you're broke, right? Because you just begin to suck. So I'm just going to pause that right there. This diagram is really a guideline. It's not a law. This triangle is constantly violated by all types of people in our daily lives. Like you can be completely unhealthy, watching TV all day, eating junk food, taking 15 medications, completely alone, hating the world, right, and broke at the same time. So this is more of a guideline. It is not a law, and people are highly resilient creatures, and they violate this law all the time. So I'm just going to click this down, and we're going to get into a more serious triangle here that is absolute law, and you cannot violate it when you're talking about construction. So this is the reward workload efficiency triangle. I created this little graph here, and we're just going to breeze through this system. So this triangle is really codependent and interdependent, with these three things exerting enormous pressure on each other. So let's look at if the workload for your construction project is, I put bad right here, it's massive, like the job is massive, right? And we're going to mark it red. And you're really slow at it. You're completely inefficient at doing it. If you have two red corners in this system, any two red corners, the third one will always turn red. Doesn't matter how rewarding this construction project is, if it's too big and you're highly inefficient at it, you're not even going to start the project. You're not going to do it. Doesn't matter what the reward is. If you're inefficient, right? If you're really slow at it, but the workload is not that much, it's in the green. If you're really inefficient, you're a slug, and it's not rewarding whatsoever, there's no point of doing it. If you're inefficient and it's not rewarding, you're not even going to start the job. It doesn't matter what the workload is. You're not going to do it. So again, two corners that are in the red, turn the third one red even if it's green. If the reward is in the red, there's no point of doing it. If the workload is massive, doesn't matter if you're efficient at it. If the workload is massive and there is no reward, you're not going to start the project. You're not going to do it. Again, two reds turning the third one red. Every construction project has to be a green triangle on all three corners. So let's look at a different relationship using now the green marker. So if the workload is green, if it's not that much work, and you're highly efficient at it, the reward, it can be red. I mean, there's no point of really doing it. But if the workload is tiny and you're highly efficient at it, you can get it done. You can get it done as a hobby, as an art piece, right? It doesn't matter that there's real no point of doing it. You can just get it done. So 2 greens will always turn the third one red. Or 2 greens will always turn the third one green. Again, using some green here. If you're highly efficient at your job, and if it's highly rewarding, doesn't matter what the workload is. If the workload is massive, if it's really bad, if it's in the red, if you're really good at getting it done and it's really rewarding, the workload that is red will always turn green. Always. 2 greens attack the red and they always turn it green. And which one didn't we do? We didn't do, if it's highly rewarding and the workload is not that much, it really doesn't matter if you're inefficient at it. It doesn't matter. You're really slow at doing this, but it's really rewarding. I mean, this is going to feed you, right? And the workload is not that much. You're always going to do it. You're going to build the project. So this reward efficiency workload ratio or construction principle cannot be violated. Every construction job is always a green triangle. So from here on forward, when you look at a site of any kind, keep this principle in mind, and we're going to discuss 2 different projects in our ancient past, and then 2 projects in Peru. So the first project I want to clip with this, implementing this system, is the Great Wall of China. Okay, the Great Wall of China was a construction job that lasted for like 2,000 years, right? Several dynasties were working on it. So the workload, it's worse than bad. It's worse than bad. We're going to give it an infinity sign. I mean, this wall stretched for 20,000 kilometers. It weighed 50 million tons. So the workload is astronomical. It's worse than red. It's black, it's green, it's red, it's brown. It's not green, sorry. And were the Chinese efficient at it? Actually, they were. They were highly efficient at it. They had hundreds of thousands of slaves, military, Chinese engineers and architects, all swarming this project. They had multiple building parties simultaneously moving towards each other at different points of this wall. And this wall was literally coming together before your eyes. It wasn't that tall. It was like, a 3-story building, right? They were quarrying bricks right on site. It was just ants, building ants, just getting this thing done. And because they didn't have to complete the entire wall, because the wall became functional as a section was built, like after a week a section is up, you put security on it, right? You put men with bows and arrows on it, and boom, that section of the wall is online. So they were really efficient because they didn't have to get the whole workload done over the course of 2,000 years. And was it rewarding? It was highly rewarding. I mean, we're talking about national security here, right? So that's why the Chinese dynasties worked on it for 2,000 years, because it was obviously rewarding. It was paying off. So efficiency, reward are in the green. Workload doesn't matter. It turns green. It doesn't matter that it was an infinity sign before. They got it done. Highly rewarding, super efficient. Okay. Green triangle for the Great Wall of China that did not violate this construction principle. We're looking at the Colosseum now. So this is the biggest Roman project. It was started in some 69 AD and lasted for 10 years. So the workload is bad, moderate. We're just gonna, we're gonna paint it. I'm gonna paint it moderate and bad. So massive workload, the biggest building the Romans built, but we know bigger structures like the Great Wall of China, for example. So it's okay. Well, the workload is massive, enormous. Were the Romans efficient at it? Yes, they were highly efficient. They put something like 60 to 100,000 men on it. Again, Jewish slave labor, but they had Roman engineers and architects managing these slaves, and they actually had two contracting companies two contractors building at the same time, building two halves of the Colosseum. And they used state-of-the-art equipment, cranes, right, tools. So this project had to be completed really fast, and that's why this project is turned out really crooked. There's not a single arc that matches there. I've seen a special on it. Somebody was analyzing it. I mean, it's the most crooked Roman construction job ever, right? They didn't need it to be precise or beautiful. It had to be functional. It just had to be, the skeleton had to be raised and the games needed to be launched. So in 10 years, they banged it out. I mean, they were really, really efficient at this build. And the reward, well, hell, the lives of the Senate depended on this job getting done, because the herd had to be occupied, entertained. If the herd is not happy, that puts pressure on the controlling elite. You get the point. It was a really rewarding construction job, and it was a massive, massive success in the end. So efficiency, reward, peaking green, workload, doesn't matter. They banged it out. Again, another green triangle. Green as day. Okay, now we're looking at Ollanta Tambo by this goddamn girl is bombing me on WhatsApp. So Ollanta Tambo and our epic diagram. Were the Inca efficient at this job? No, they weren't. Even if the CIA flew down there with Chinooks, with gear, with heavy machinery that they had to assemble, that they unloaded off those Chinooks, they would have heavy machinery running up and down this mountain. They'd have cable systems set up, fold out metallic bridges that they would haul in. It would be like a $200 million operation with hundreds of men on site. It would take them months, right? With 24-hour operations with lights on, it would not take a week, right? This is a massive job that, and if you're talking about just manual, like chiseling Inca, quarrying these stones, they're inefficient. No matter how you look at it, they're inefficient at doing this. The efficiency goes red. How is the workload? The workload is massive. The workload is massive. They could have built a wall out of this bedrock right here. They had plenty of material, but instead they chose to be shot across the valley to quarry these stones. They chose these stones to be massive, increasing the workload, decreasing their efficiency in the completion of this project. So the workload is massive for anybody. This is a massive workload. It's in the red. This project rewarding? What is this project? You got to ask yourself, what the hell is this? It's a retaining wall that's not retaining anything. This whole village would have been just fine without this superstructure here. This is not, how big is this terrace for agricultural development? Is it worth to spend years building this wall out of these massive blocks when they could have just built it out of little ones, creating this agricultural terrace? So there is no reward for this. It's not a sacred temple, right? It's not a tomb that the Inca just had to erect. On top of it, they have all of these other blocks that they didn't utilize for some reason. So this whole thing makes no sense. It looks like it's in ruin. in fact. It looks incompleted, and there is no reward for it. So this whole triangle is simply in the red. You don't even have a single green point, and no matter how much mental gymnastics you're going to do when you put the Inca into this formula, the workload turns red, the efficiency turns red, and there is no reward for the Inca. The Inca were highly practical, grounded, normal people, right? They weren't religious stone nuts. They just had to erect random stone structures. They were just trying to survive here and not kill thousands and thousands of man hours on God knows what. So this build completely violated our construction principle on all three corners. Another Peruvian job. We've all seen this. Okay. It's elusive how much materials actually came out of here, but let's say for sure that these two sections were the last ones that came out of this cliff. Ben and the Serpent Brothers go into a discussion about it, and they're like, well, there's no way they were quarrying blocks out of here because you can't cut the back out of it. What they're saying is whatever material that came out of this cliff was not utilized. It was turned into rubble, essentially. So this isn't even a quarry site. This is just a carving and a cliff. Again, if you're talking about tools, efficiency, putting men on it to do this, how many men can you put on this? 5, 6, right? You're inefficient. If you're going to be scraping, wrecking stone chisels there with little stone hammers for months and months and months and months, this would take months of a modern stone crew with diamond blades. They would be cooking diamond blades here, breathing silica with water, hosing it down with water all at the same time. I mean, this would be a mess of a job in the modern era. That would take a long time. So the Inca are highly inefficient at this job. No matter how many men you throw at this job, it's a limited amount of men that you can throw on it. So the efficiency is red. It's in the red. Workload, again, massive. We're talking about the Inca. If you're sitting on the same spot for months, right? The Great Wall of China, we're talking about it being erected daily, right? They had progress daily. But if you're sitting on the same spot for months and just carving rock, the workload is massive. And what is the reward? There is no reward. It's not a temple. It's not an agricultural terrace. It's not a building. It's not a quarry site. If it was a quarry site, you would have, some remnants of broken pieces. They could have just, they wedged out, boom, piece breaks off, they take the block. But instead, they cleaned up the backs. It's not a quarry site. So this job makes no sense. There's no point for it to be done. So the reward is red. It's red. So all 3 points, again, are red. And it completely violates the construction principle. There isn't even a single green corner that will help out the other two. Again, when you're talking about the Inca with little stone chisels, little simple agricultural people, you just want to eat, chew cocoa leaves and hang the fuck out. When you put them into this job site, everything is red. So the whole point of this presentation is when you look at a site like Ollantay Tambo, you don't put on SGD's brain and say, well, they could have done it. Well, let me think. Let me think how they could have dragged these blocks up here. No, you gotta zoom out and say, what the hell is this? What is this? What was the purpose of this? Were they efficient at building this? The Inca with little stone hammers and chisels. What is the actual workload? What was the logistical plan for this? Why didn't they utilize these stones but shot across the valley as if they had shortage of bedrock? When they don't, you just dig into any of these mountains. You don't need to go across the valley. Oh, but they needed granite. For what? For magical properties of granite, it's a retaining wall, right? It's a retaining wall, just like any of these retaining walls. So this site holds no reward. They were inefficient at building it, and the workload is massive, and it's incomplete. If you don't know what this site is, do not begin to talk about who built it and how. That is, elementary linear logic that you can rely on. Whenever somebody starts telling you how something was moved or how something was built, first find out if they know what it is that they are looking at, right? If some aboriginal found like a metallic part in the jungle from I don't know what, some mysterious metallic part that was manufactured, he's not going to start talking about who built it and where it came from. He needs to identify what this part is first. And these parts have not been identified. Simply, nobody knows what this is. And yet this debunk crew is telling you and telling you and telling you how it was built and how easy it was to move it and who built it, right? It's ridiculous. It's fucking ridiculous. So that's all I wanted to present in this video. I hope you retained that construction principle with the shittiest diagram on the internet. I'm sorry for that. You know, I suck at drawings. I suck at computer stuff in general. But I think this principle should stick in anybody's head who understood it. So thank you. You'll see me again. We're going to look at more of SGD's videos in the future. Bye-bye.